Hey there, Matt Groden here for Why Math Why in another installment. This time we're going to debunk something that was learned years ago, or maybe you're just learning now, or maybe your little ones are going to be learning later on, which is dividing a fraction by a fraction. And we're going to talk about this awful mnemonic, keep, change, flip. And I say it's awful because there's no math behind it unless you understand why it works, right? Otherwise, we're just memorizing gimmicks. That's not math, that's gimmicks 101. So let's just illustrate what keep, change, flip is first. You've got a fraction, 3/4, divided by 2/3, and our goal is to simplify it. So to do that, we keep, there's your keep, right here, your fraction. Then you change the sign, you change division, there's your change to multiplication, and then you flip this fraction right here. So flipping that fraction is 3/2, and now you can simplify it, multiply across, and you get 9/8. So here's the thing though, why the heck does that work? So I'm going to go over this conceptually. We'll go easier to harder. So I've got a few different explanations for it, and they're all, in my opinion, pretty darn cool. So let's start with a simple one. Then you might want to turn off the video and say, you know what? That does it. I'm satiated. Or you might want to keep going from there. So the first example of why this works, if you take a look at 3/4 divided by 2/3, and I'll just give you a specific example. I'll go over a proof much later in the video. 3/4 divided by 2/3. Conceptually, that's the same as doing 3/4 divided by 2. Right? Those two parts right there. And when we divide by 2, aren't we just taking a half of something? So if I divide by 2, I'm taking a half of something. And then at the same time we're dividing by 2, we're also dividing by 1/3. So if I divide into thirds, if I cut something into thirds, take a rectangle and I cut it into thirds, we have one piece. When I divide it into thirds, though the pieces are smaller, I have more pieces. Therefore, I am doing the definition of multiplying. So dividing by 1/3 is the same as saying, how many pieces will I get when I divide into thirds? Well, I'll get 3 times as many pieces. Therefore, 3/1. And look at that. That's the same as 3/4 times 3/2, which gets us to our answer up there. So that's one reason why keep, change, flip works. At this point, if you want to say goodbye, that's cool. Go on and watch another video on Why Math Why, or just think about this for a little bit. If not, what's coming up next is a little bit more of an advanced idea behind it, and then an even more advanced proof after that. So if you're leaving, see you later. It's been real fun. I'll see you in the next video. If you're not, stick around. Here we go. All right, and here we go. So another way of looking at that same problem, 3/4 divided by 2/3. Well, let's set it equal to something, I don't know, let's call that question mark. All right, 3/4 divided by 2/3 is question mark. Now the definition of division is what times 2/3 gives us 3/4. And then let me use an easier problem to illustrate that. Let's say we have 16 divided by 8 equals what? You're really saying what times 8, or question mark times 8, equals 16. And so we divide both sides by 8 in that equation and we would get 2. So we can use the same logic here. What times 2/3 equals 3/4? That would be using the definition of division. Well, let's undo 2/3 times question mark. A couple things that are being done here. Question mark is being both multiplied by 2 and divided by 3. We'll undo division by 3 by multiplying both sides by 3. So that leaves us with 2 times question mark equals, and for the sake of what I'm trying to show here, I'm not going to simplify this. I'm just going to show that it's just times 3. Then we have 2 times question mark, so I'm going to undo that by dividing both sides by 2. Now if I divide this side by 2, division by 2, maybe I'll go back and say division by 2 is the same as multiplying both sides by 1/2. Ooh. So you get question mark, which is our solution, is equal to 3/4 times 3/2, which is the flip of this being multiplied by that. All right, so if you've had enough, again, this is chapter 2. You can certainly leave the video, but if you want more, there's more. Let me show the proof in general. Let's say that we have some fraction a/b such that neither a nor b is equal to 0. And c and d, where neither c nor d is equal to 0. So I have a/b is divided by c/d, and we want to know what that equals out to, some number k. So if I divide that out, I'm going to use a very similar logic here. The definition of division is saying that k times some number is going to give us a/b, right? Well, let's see what that number is. Well, let's take a look at this. If I have A over B divided by C over D, well, again, I'm going to use the definition here. I want to show that this is the same as multiplying by D over C. So the definition is that, well, we're going to have some number K times C over D is equal to A over B. Right? That's the definition of division. What number, K, times C over D gives us back A over B. Okay, so I'm going to solve this very similarly to how we did the last one. K is being divided by D. I want to solve for that number that we're going to get out of here. So I'm going to multiply both sides by D. Those cancel. At the same time, I can well, let's go on to the next step. KC equals A over B times D. Then I'm going to divide both sides by C to get K alone. Well, dividing by C is the same as multiplying by 1 over C. And lo and behold, you get that your answer is also going to be equal to A over B times D over C. So we've proven once and for all, keep, change, flip. Don't use keep, change, flip. Just understand the math, peeps. All right, that's it. That's chapter 3. I'll see you in the next video. That was a really long one. I hope you enjoyed this guy. I'll see you later. Keep mathing hard. Peace.